Hello, good day everyone. Today we are going to go ahead with another model in geometry. This is not really known as a theorem, but it's a very important result because it's very useful. Let's see what the result is like. The result is this. That in a right triangle, you take the altitude from the right angle vertex you take the altitude on the hypotenuse, and now we name it. The right angle is at A, BC is the hypotenuse, and AD is the altitude. Then the result says that in a right triangle, if you take the altitude on the hypotenuse, if AD is the altitude on the hypotenuse, BC, then AD square, the square of the length of the altitude, is equal to BD into DC. That means the product of the two parts you get from the hypotenuse. So AD square is equal to BD into DC. Here is the model for it. We have a right triangle ABC, and from A we have taken an altitude to the hypotenuse. In the model what we have done is we have cut the triangle along the altitude, and after cutting, if you can see it, what we have done is that the two lengths which represent the altitude we have marked in red, and the two parts of the hypotenuse, whichever way is big or small, it doesn't matter, we have marked them both in green. One of them we can call BD, the other CD. Okay, now the result, according to the result, we want to prove that the square formed by this red has the area equal to the rectangle formed by the two green ones. And this is how we do it. We have a big triangle here, and we have already got two pieces from the given right triangle. What we do is, we fit the two orange triangles at the two acute angle vertices, the right angle remaining free. And now let us see what remains. Suppose from the purple triangle I take away the two orange triangles. What shall we be left with? We shall be left with a rectangle, the purple rectangle here, whose sides are, both of them are green. So the green ones we know are BD and DC. So what we are left with here now, after removing the two triangles, is BD into DC. Okay, what we do now is, we move this here and take it, this one up there. All we have done is taken the smaller triangle below, the bigger triangle up. And again from the big purple triangle, we remove the two small orange triangles, and what we are left with is a square. How do you know it's a square? Well, I have both the red lines here. So I know that it is a square, and also that its area is the square of the red, and the red was the altitude AD. So this is AD square. What have I done? I took the same big triangle, put the same two small triangles and removed them, and I am left with now, what I am left with is AD square. the same operation had been performed both the times, and therefore from equal big triangles we took out the two small triangles. What remains has to be equal, and therefore the two are equal. So that takes care of the model. So with the help of the model we have shown that AD square is equal to BD into BC. Now we try to make a model for it. How do we make a model? Well, the first part is very simple. As we know, we have to take a right triangle, take the altitude and cut along the altitude. Oh, okay. So here is the right triangle, and I folded along the altitude so you can see the altitude, and now we have to cut along the altitude. That's what we do now. So now we have two small triangles like here, cut along the altitude. Now we have to make the big triangle, and any big right triangle will not do. It has to be the proper size. And what is the proper size? Let us check once again what it was. See, what we did was, what are the lengths of the two? Of course it's a right triangle, so it has to be a right triangle. Now we are concerned with the lengths of these sides. One side you can see is the small green one and the red one. Small green one is the smaller of the two, BD and DC, and this is AD, and that is on the lower side. So we are now taking this is BD and this is AD. So here is our triangle, here is the AD and here is the small BD. We put them along here. This is our BD and this is our AD. And now what was to be done next? The other lengths we did not measure. We already took BD and AD. Now how much is this length? This is AD. And this is the other portion of BC. We have taken BD, the other portion is CD. So this is AD plus CD. So this is AD plus CD, and this is the triangle. So once we shall get this, and the next time we shall get something like this. Now this is not really important in making the model. I was just trying to show you how you can use it. But in short, the length of one side is AD plus CD. The length of the other side is AD plus BD. And now this triangle will serve as the base for your model, with the two pieces fitting in alright, like this. Okay, so that takes care of the model. Now, I told you in the beginning that this is a very useful result. This doesn't fall within the purview of demonstration of a model, but I just can't resist myself. I'll tell you what is the most important use of this result. It is in constructing a line segment whose length is square root of a given number. Alright, so you are given a number. Now construction means only ruler and compass. You are given the length of a unit. Now this is your unit. Now construct a line segment whose length is square root of 15. We know square root of 16 is 4. It has to be little less than 4, but how much? We don't know. And we cannot measure. We don't have a ruler. What we do is, we are given 15, remember, and we know units. So along a line segment, we can take these units 15 times and this unit 1. And now what we do is draw a semicircle with this as the diameter, and at this point where we have 15 and 1 parted, we draw a perpendicular, and wherever this meets this will be your A, this will be your D, this is your B, and this is your C, because you will now be able to relate it with our model. This is always a right angle because it is in a semicircle. So this is the right triangle that we have. We have AD perpendicular to the hypotenuse. So AD square, if you call it x, x square will be equal to 15 into 1. So we shall have x square equal to 15 into 1, and that makes x equal to root 15. So that's how we construct square root of natural numbers with the help of this theorem. Okay, try to make this model, try to work out with it and have fun. Thank you.